Our final talk in this session is Pooja Rajkumar,
Yep.
Rec Tools. There we have, oh, no, the title's changed. The title's changed, so.
Okay, yeah. Mm-hmm.
Perfect.
Okay. Good evening, everyone. Thank you so much for attending my session. So yeah, the title has changed a little bit, but the essence has still stayed the same. The purpose of this project is to dive a little bit deeper into recommender systems, the role they play in the way we interact in businesses, and the role it plays within the data science world. So I'm sure a lot of you guys are familiar with Amazon, correct? A lot of people use Amazon and buy products off of Amazon, sell products off of Amazon, and Amazon actually uses a recommender system every time it says, hey, do you want X, Y, or Z product based on your previous products or the previous things that you've bought? And so this package, Rec Tools, delves a little bit deeper into that. So suppose we have a friend, Mary, and we want to know what Mary would give the rating for the movie Captain America. We know her ratings for the Avengers, and we know her ratings for the Little Mermaid. And based on these ratings, we want to give a prediction. We want to guess exactly what she would rate Captain America. And right now, there are several packages in R that are useful for recommender systems, such as Recommender Lab, which uses collaborative filtering, and Recosystem, which uses non-negative matrix factorization, which has kind of been blowing up recently. So to go into a little bit more detail about what that exactly is, suppose we have a data frame A in the following format, where each row refers to a user. So, for example, if we wanted to look at item 1, movie 1, the rating would be 2, and so on and so forth. So I want you guys to notice something particularly interesting about this data set, which is that most of the time this data set will be empty. Most of the time the data set will be filled with zeros, and that's because not every user has rated every movie. And so what non-negative matrix factorization does is basically taking one big matrix A and breaking it down and decomposing it into two smaller matrices, such that when multiplied, you would get an approximation of the values in A. And so we really find that in this research, I've worked a lot with the Movie Lens data set, which has a column for user IDs, movie IDs, and ratings for each movie per user. And I found that there's kind of a sweet spot when it comes to determining the rank of the matrix. And I found that the sweet spot tended to be the value 10. And I think I hypothesize that's because the larger it gets, the more you're overfitting, but the smaller the rank, the less you're taking into account the real data. So really the sweet spot here would be 10. And so let's go into a little bit why we would need Rec Tools. Rec Tools basically improves the accuracy based on current packages in R. It incorporates covariates such as age and gender and other demographical things that we don't typically look at when looking at these ratings. And it also performs cross-validation, so you can determine the accuracy for your particular data set. And so we're looking at three key factors here when we're trying to determine Mary's rating. First, we want to see how harsh is Mary? Is she an easy grader? Is she a harsh grader compared to the overall data set? And we also want to look at the movie. Did Captain America do fantastic in the box office? Did it get fantastic ratings, or did it get poor ratings compared to the other movies in the data set? And lastly, we want to look at how do users rate movies in general? Are people typically harsh graders, giving typically 1s and 2s on a 1 to 5 scale, or are people giving 4s and 5s, a little bit higher on the scale? So I'm going to be focusing on two of the main estimations of these parameters, since we already talked about Recosystem, which uses non-negative matrix factorization a little bit earlier. So stepping into method of moments, we're using a two-way ANOVA model, which is kind of your basic statistics model, in which your alpha I and beta J are random effects. And alpha I would be Mary's tendency to rate movies, so we look at the average of all of Mary's ratings, and we look at the overall rating for all movies, and we'll see how she fares compared to everybody else. And we would do the same thing for the beta J. We would look at all the ratings for Captain America and see, comparing against all the other average ratings to see how well it fared. And the epsilon is just the combined effect of all unknown factors. And so here, in order to predict Mary's preference, we want our Y value to basically be what we were talking about earlier. We are basically estimating it based on the average of all of Mary's ratings, subtracted by the average overall rating for all movies. Same thing with the beta J. We want to look at all of the ratings for Captain America and see how well it fares with the average. And our estimation for mu in this case would just be the estimation of the overall data set. And so another way that you can predict using this package is using maximum likelihood. And how we use it in this package is we use LME4, which is a current library in R. And what LME4 does is it basically does maximum likelihood for you. And our package, RecTools, will call LME4, extract the estimated y.j, and the overall average of the ratings from the LME out. And then we just plug that back into the original model. And so based on all of these different methods, it really comes clear which one comes on top. Based on accuracy alone, it seems that method of moments, the two-way ANOVA model that we were discussing earlier, did pretty well compared to the other methods. And in fact, it was also a lot faster. And another thing that is incorporated in this package is that all of the methods are parallelized. And this is kind of a big thing, because at this point, non-negative matrix factorization is kind of it's kind of become a huge deal, especially in terms of recommender systems. But we can see here that there are also alternative methods, such as method of moments, such as maximum likelihood, that are incorporated in this package that are not only more accurate, but could be a lot faster too. And one thing that I just wanted to note is that these timings also include cross-validation time. So basically, just checking to make sure and calculating the accuracy that was included when we were timing this. And just a couple of graphs. This package also included a plot attribute, which is actually kind of helpful, especially when we're talking about maximum likelihood, because we want to make sure that our alpha and our beta values are approximately normal. And so using this plot function within the package could actually be super useful, especially when we're trying to determine which path we want to take. Do we want to use method of moments, maximum likelihood, or if we wanted to use RICO systems, which again uses matrix factorization. And so by taking a look at the graph here, it's clear that it doesn't really fall under normal distribution. It is bimodal, so it seems as though there are two subpopulations at play here when we're looking at these estimated beta, which in this case would just be the movies. So perhaps it could be genre, like certain types of movies. Maybe they need to be separated by genre, and then we try and estimate the values. We're not really sure, but it's clear from this graph that there are other forces at play here. And so looking at this graph, we would try and think like, okay, maybe using method of moments would be a little bit better, especially when we're trying to figure out this beta value. And the same thing for the alpha. The alpha value seems to be approximately normal. So it seems as if we could probably use maximum likelihood in this case. And this smooth scatter plot, it seems that there's a lot going on here, but not really sure. But it does seem clear that the alpha and the beta values are independent of each other, which is important if we wanted to use maximum likelihood in this case. And so I just wanted to go over a couple additional package features that really make RecTools special. And the most important one being covariates. By adding covariates such as gender and age, we can see beyond the scope of just numbers. we can see beyond the scope of, okay, what are Mary's ratings like? We can also look at how does her gender affect her ratings? How does her age affect her ratings? Her occupation, where she lives? Like, there's so many other factors that go into how one person would simply rate a movie that adding covariates is kind of key here, especially if we're talking about people who have fewer ratings, because we often found that people who had a lower number of ratings tended to rely more on covariates. So, for example, if Mary didn't have a lot of ratings, let's suppose she only rated The Little Mermaid because she just loves Disney movies. Using her covariates, like thinking about which area she lives in, what her gender is, what her age is, actually played a significant role in determining her predicted rating. So this could especially be helpful for people who are trying to figure out other third-party forces that take a role, especially in looking at data, because it's obviously never black and white. All functions, the method of moments function, the maximum likelihood function, have a covariate capability. So if you have a data set that has the user, the item ID, and the rating, and you also have a covariate, an option to add a covariate, this could be really helpful. And the second thing that this package includes is parallelization, which actually plays a significant role for large data sets. I mostly worked with the 100K data set, especially when it came to the movie lens data. But when I was playing around with the 1 million lines, or the 10 million lines, or the 20 million lines, there was a significant difference, a significant amount of time saved from parallelizing all of these functions. And another feature that is included in RecTools is focus groups. So there's an option to see which users are most similar to each other. This could be used to help form focus groups to determine what a typical user would like a movie or not. And the last feature that this package includes is nearest neighbor prediction. So basically, let's look at Mary, but let's also look at her friends. Let's look at John. Let's look at Paul. Let's look at her friends who have rated other movies similarly to her. But let's try and see their ratings for Captain America and see how it would compare to Mary's rating for Captain America. And so that concludes my presentation. Thank you so much for listening.
Any questions? Yeah.
Yeah, So you can use other covariates such as age and gender to determine how someone would rate an item.
So in my experience, I've noticed that there are people, like when I've done surveys, that give 9s and 10s, and there's some people where the 9 means something terrible happened, like they just always give a 10. And then there's other people, like when it's voluntarily rating, like on Amazon or, they only rate things 9s or 10s because they only talk about the things that they like. Like it's really hard on Amazon to get a lot of helpful votes when you give a bad review. Like it's really have to make it a really solid case.
Yeah.
Like there's helpful votes for a bad review. So do you have any strategies for like teasing apart, like when somebody's just getting 9s or 10s and it's a voluntary rating, it's not like a sample. You're not sampling. How do you know what the chance there is?
I think, especially for RecTools, I think that's kind of where the tendency comes in. The data set that I ended up using for this project was movie lens data, so it wasn't necessarily of something, it was voluntary, but there were a lot of users and a lot of ratings, and so looking at the average ratings overall and looking at the tendency to rate things high or low, because I think that's kind of where it plays in, right? To see, oh, if someone rates something only when they really, really like it or they really, really hate it. But let's look at the average. Let's look at how people fare generally. And by averaging that all out, it kind of takes away a little bit of that noise. And then we look at the individual ratings compared to that, and that really, it reflects the tendency of the actual user.
Last question? Oh. Oh, all right. You can have the last question.
Have you benchmarked your solution against something really simple? I remember a story a friend told me when they were having recommendation competitions at Amazon, and they had about 50-something submissions at the end of the competition, and 48 of these submissions lost the benchmark that said take the most popular movie in the catalog at that time of submission and recommend it to every single user.
Oh, interesting. I guess in this case, the benchmark would be the average. Like, I'm not exactly sure, but I think in this case, it would probably just be like the average rating of all movies, of all users.
Pick the movie with the average, with the best average
Yeah.
rating out of all the movies, and recommend it to every single user. Does your system do better than that?
I would have to try that, and then I'll definitely get back to you on that.
Let's give it another hand. Thanks very much.